Lesson 12.3, Sample Space by Mrs. Wickens. 12-3, Sample Space. The Indiana Academic Standard is 7.4.5. Our first definition is sample space. It is the collection of all possible outcomes in a probability. Pause the video at this time to write down the definition. At this time, pause the video if you need more time to write the definition. The other concept we're going to talk about today is the counting principle. The counting principle is a mathematical way of finding all the possible combinations. Suppose there are m ways of making one choice and n ways of making a second choice. That would mean that there are m times n ways of making your first choice followed by the second. That's a little hard to think about in terms of algebra. So let's think of a real-life example. If we have 5 sizes of shirts in 7 colors, then you can choose 5 times 7, or 35 shirts. You would have 35 choices of shirts. Now, if we want to think of another real-life example, we could think of outfits. If you have 5 pair of pants, and you have 9 shirts. If you wanted to find how many total outfits that you have, you could take 5 times 9 and find that you have 45 different outfits. If you need more time to finish this, writing down these examples, please pause the video at this time. Now we're going to go on to example number 1, finding a sample space. We're going to think about a spinner that's divided into 5 equal sections labeled A through E. We're going to create a table to show the sample space for spinning the spinner twice. Here's our table. Take a moment to copy down the table. The choices across the top show us if we would spin it we have choices A, B, C, D, and E. Down the side, again, A, B, C, D, and E. All of the choices in the middle show all the possible outcomes. If you need more time, pause the video at this point to copy down the chart. Right, now we're going to find the probability of spinning at least one D. If you look at the chart, we can find all of the places where there's at least one D. We have a whole entire row that has one D. That would be 5 choices. Then we have 4 more possibilities that contain one D. So that gives us a total of 9 outcomes with at least one D. There are 25 possible outcomes in the entire chart. So the probability of there being one D is 9 out of 25. We can use the same information to figure out the probability of having at least one vowel. So we're going to do the probability of one vowel. I'll clear off what we did before so that we can see it. Again, we're going to do the probability of one vowel. So we would mark all the columns that are, we can do columns. So we have a column here that contains vowels. We have a column here that contains vowels. So there's 5 and 5, which gives us 10. But we also have 3 here and 3 here that are not included in those columns. So that gives us a total of 16 combinations that contain a vowel out of a total of 25. So the probability that a combination would contain at least one vowel is 16 out of 25. At this time, pause the video if you need more time to copy down the notes. Now we're going to do the quick check. We're going to create a sample space for tossing a coin. Actually, we're going to toss 2 coins. So here's our sample space. We create a table where we have heads across the top and heads along the sides. So we have heads, 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 tails, tails, heads, tails, tails. Again, pause the video if you need more time to copy that table. Now, we need to find the probability of getting 2 heads. So if you look at our table, we have one section or one combination that has 1 head. So that would be 1 out of 4 possible combinations. Let's try another one. Let's find the probability of getting at least 1 tails. So we look at our combinations. We actually have 3 that have at least 1 tails out of 4 possibilities. So the probability of getting at least 1 tails would be 3/4. Again, if you need more time, pause the video. Now we're going to create a tree diagram. We're going to look at a scenario where you're either going west or northwest and you're traveling by train, bus, or car. We can draw a tree diagram, and when you follow a tree diagram, you follow it from left to right. And so we need to fill in our possible combinations here. We have a train that's heading west, then we have a train that's heading northwest, next we have a bus heading west, and then a bus heading northwest. Next we have a car heading west, and a car heading northwest. That gives us a total possible outcome of 6 outcomes. Now let's find the probability of a random selection that results in a bus trip west. If you look at all the combinations, there is 1 favorable outcome, the bus traveling west, out of 6 possible outcomes. This makes the probability to be 1/6. Now we can also check our possible outcomes using the counting principle. We had 2 directions of west and northwest, and we had 3 modes of transportation, train, bus, and car, which gives us a total of 6 outcomes. The counting principle allows us to verify that our tree diagram was drawn correctly. Now let's take a look at coin purses. How many kinds of coin purses are available if the purses come in small or large sizes and the colors red, blue, yellow, and black? So we have 2 choices in sizes, but we have 4 choices in color. That gives us a possible combination of 8 combinations. So there are 8 different kinds of coin purses available. Please pause the video if you need more time. Suppose an airplane is added as another choice in example 2. We need to draw a tree diagram to show the sample space. So we'll have a train, a bus, a car, and a plane. We draw forks off of each of those for each of the directions. So 2 off of the train, 2 off the bus, 2 off the car, and 2 off the plane. Then we'll add the directions for each of those. West, northwest, west, northwest, west, northwest, and west, northwest. And finally, you write the combinations out. Train west, train northwest, bus west, bus northwest, car west, car northwest, plane west, and plane northwest. Please pause the video at this time to finish drawing your tree diagram. Now we're going to find the probability of selecting an airplane at random for your journey. So if we look, we have 2 planes that we can choose from. Out of the total number of combinations, 1, 2, 3, 4, 5, 6, 7, 8. That simplifies to 1/4. We can verify our number of outcomes by the counting principle. We had 4 modes of transportation. We had 2 directions. 4 times 2 is 8 possible outcomes. Let's do another counting using the counting method to figure out the number of possible deli sandwiches that you can have. We have bread and we have meats. We have 5 different breads and we have 6 different meats. That gives us a total of 30 different sandwiches that we can choose. I challenge you to go to Subway's website and discover how many different breads they offer and how many different meat choices they offer, and come up with how many sandwiches you can make at Subway. That doesn't even include all of the vegetable choices and the dressing choices. Good luck with that. Also, you can go to phschool.com and try the online quiz, ARA 1203. You have completed the notes for Lessons 12-3, Sample Space. There's an additional video that you can watch for more examples and to try your hand at sample space problems. If you watch the additional video and take notes on it, you can receive extra credit. Good luck and see you in class tomorrow.